So I'm really excited to be here. I know people say that, but I'm really excited. I'm from Philadelphia, where it was below freezing today. I'm here to talk about Polymer, web design, development, web performance, stuff that I love. So I'm really super excited to be here. I know snacks are next, and I have a lot to cover, so I'll see what I can do here with the time I have. But really, I'm here for you. So I want to get a sense about who all you beautiful people are today. So who here has actually heard of Polymer before? I'm going to do a hand raising thing. All right, lots of hands. Who has actually played around with it before? A couple hands. Who shipped something? Nice, got a couple people. Excellent. Who would say they do web development work in their day-to-day? That's everybody. Great. How about design? Any designers? Nice, my people. I actually started off as a graphic designer back in the day, and as my career has progressed, I've just been doing more and more development, and now I do pretty much all development. But when I can talk about design, I get excited about it. So I'm really excited to be here about that. Also, I'm going to be posting my slides online afterwards, so I'll post it to Twitter and to the Slack channel as well. So afterwards, don't feel like you need to write down anything, just it'll all be posted later, so you can check it out. And I mentioned I'm visiting you from Philadelphia, so I work at Comcast there. I've been there for 10 years. If you've heard of Comcast, it's one of the largest cable TV, internet, and phone providers in the US. We also own NBC Universal, so if you've been to Universal Studios, that's actually Comcast property now. So if you did, thank you. It's a good time there, I know. And we've created well over 500 web components now at Comcast in the time that I've been there. We get to use a variety of web technologies at Comcast. So this here is the My Xfinity website. This is where a lot of our customers start their day to check their email, get the latest news. And this was built with Ruby on Rails and actually has some jQuery in it. This is the My Account website. So this is where customers can go pay their bill, manage their devices, view their account, that kind of thing. And this was built with Angular. This is the Xfinity Home website. This was the first Polymer project we launched at Comcast. So this allows customers to view their home cameras, secure their home, do some home automation, like toggle lights on and off, that kind of stuff, set their thermostat. So this was built with Polymer 0.3, actually. We started it, and we've updated it since then. This is the X1 platform. This is kind of what we're best known as, Comcast originally being a cable company. And this is basically the UI across all devices. And the web UI for X1 is also built in Polymer. And the most recent Polymer project is one that I worked on, which is XFi. So if you've seen this commercial where like the mom's at home and she turns off the internet in her house and all the kids just happily come to dinner, you turn off the internet and the kids scream. That's the actual use of XFi. But this has been a fun project to work on using Polymer, and this is most recently I've done at Comcast. And I'm here to talk about design systems. So why is that even a thing? Like, how did that come to be? So basically, when designers and developers are building designs for individual projects, it's nearly impossible to maintain consistency from project to project without some sort of system in place. Even if you define a UX vision at the start, that's really just the start. And then once teams actually start iterating on that vision, it can lead to things like this. So we have 3 loading dots across our Xfinity product. So if there's loading, you're supposed to get this standard 3 loading dots. And if you look at this, you'll see that there's actually very slight variations in each of these 3 loading dots. And basically, it's like we came up with these dots. There was one way to do it. And for some reason, there were these tweaks along the way. And as the end user, you may not really notice that difference. But as myself as a leader and other leaders in Comcast, we see this and we're just like, why is this happening? And a big part of that is communication. So over time, especially in a large organization, you've got teams that are going to implement this initial design. And then that's a designer may tell an engineer, this is how you're supposed to implement this design. And then the next time that happens, it's maybe a different designer telling a different engineer, or a different designer telling a different designer, or a different engineer telling a different engineer. So there's all these opportunities for things to get kind of lost in translation. And it's also possible someone may actually fully hear what they were told, but to say, you know what, in my case, there's a reason I need this specific deviation from that standard. And that may actually be true, it may not be true, but this actually leads to a bunch of different standards, which causes a problem. You're trying to standardize the way that you do things. And I was talking to our creative director of the experience design team at Comcast, and he was basically just like riffing on problems he was seeing, stuff being rebuilt. And he said this while I was talking to him, and I thought it was really embodied what I was trying to encapsulate here. So I wrote it down for you so you can all see it here. It's designers should build products that solve needs instead of spending time on reinventions. And the idea here is really, you want to be doing things that are actual problems. You want to be working on valuable things in the time that you have. You want to be working smarter, not harder. So our experienced design team went out and they created this set of design standards. And this outlined the best practices and the ways to actually create what was the brand vision for Comcast and Xfinity. So there's a website where you can go and actually view these design standards. So you could view it if you want to. It's at design.xfinity.com. Developers would go and check this out, and this would tell us how we should be building our websites and also across other devices. So for Android, iOS, for the set-top box, for watch devices, how our remotes work, everything. But it's really tough to cover everything in an all-encompassing style guide or design guide. So here's one example, and that is just a humble button. So buttons seem simple. It's something that you tap or click on a page, but there are so many variations of a single button. You know this if you've ever created a button. And our designers knew that as well, so they went ahead and they created many variations. So here are our primary and secondary button treatments. If a button is so unimportant that it looks like a link, actually that's the third column there. And then there's different states of these. There's the tap state, the loading state, if it's inactive. So they thought about all this stuff. And buttons could appear on more than just a white background. They could appear on a black background or a dark gray background, and that slightly changes the blue color. They can also appear on a background image, and then the blue then changes to white. And this is all just one little humble button with lots of variations. However, in practice, while this is certainly an improvement, it's not foolproof, and that's because what's being delivered to the engineers is an artifact. It's a set of standards, which is really great to reference that, and it's a style guide, which is also very useful, but as a developer, I can't ship the images that were given to me. I need to actually go ahead and write some code. So then what happens? Engineers and web developers, they take those style guides and they start translating it into code. And that leads to something like this. So this was a team that saw the style guide, and they also knew what they had to build, and they went ahead and they created all the buttons they needed to create and put them in a nice kind of engineering-focused UI style guide. But you'll notice that they actually created more buttons and different variations that were already in the original design standards. And this happens time and time again. So another team went ahead and they created some more buttons, and their app, for some reason, needed a blue background. And then another team had a more simple app, so they went ahead and they created just a few buttons. That's all they needed, and that's fine. But if some team here was solving a problem like this one that needed the blue background, that's just for that one team. They're not taking those ideas and communicating it up the chain and then back across the organization. And this issue is really clear when you consider how we originally handled focus states at Comcast. So this is the example of how some teams decide to handle focus states because the style guide didn't define it. So the first one just didn't even handle it. The second one basically gave it the hover state. The third one tried to do like a dotted outline around it, but it's a box shape. And the fourth one is this really nice, the dotted outline covers the, follows the rounded corners. And this is like a really nice design. And our accessibility team saw this and was like, this is actually the best way to handle focus state for buttons given our UI. And that was a non-trivial engineering feat to actually make the button look like that. And the person that did that talked about it in our internal Slack channel, but still, this app never actually went ahead and was shared throughout the company. And it's like, why did that happen? So basically, there's different frameworks in place, so it's hard to share it. And then again, just communicating that up the chain and around the company, how to actually say, this is how we're going to handle focus states across the company. The last piece I want to touch on around buttons is from this really great blog post from Nathan Curtis entitled, "And You Thought Buttons Were Easy." And he basically tells a story. Say you've got a designer, a developer, and a QA engineer, and they're going and they're working on a project, and they're going to go build those buttons. Say the average price of them is $100 an hour, and it takes, say, 200 hours to build all those variations of those buttons for the project that they're working on. That means it's $20,000 for that team to build those buttons. Now, that's just one team. Say you've got that $20,000 and you have, say, 50 teams. That could be true in a large company. That is $1 million to create buttons. Someone as big as Comcast, maybe it's even more than $1 million to create buttons. And that's just buttons, which is pretty insane. Just a button. It's like, what are we doing? What are we spending our time? What are we spending our money and our resources on? So imagine what a more complex component would be like. And since this is an expensive problem to solve, so from a development perspective, you want to go ahead and actually create a library, a shared library. But that also, it's easy to say that, but it's not easy to actually create a real shared reusable library that can be used across an entire company. You could go ahead and do this maybe within an engineering group, and that might work for the framework that that team is using, but then there's other frameworks in play inside of a company. So it presents these barriers to actually sharing things across a company. Now, despite that, Google has found success with material design. They've invested a lot in this. They're maintaining it. It's very detailed. You can go look at this and figure out how can I implement material design. And since it's the UI in Android, it's obviously very popular. And since it's so popular, a lot of the popular frameworks have a material design implementation that you can just use. So here's the React version of it. There's the Angular one, which Michael spoke about earlier. Here's the Vue.js version, and there's lots of different ways you can go ahead and get material design components. And it's like, how is this even possible? And if you look at GitHub and see who's actually contributing to this, you see how this is possible is because there's tens or hundreds, or in the case of React, over 500 contributors to these UI frameworks for that framework itself. But I think it's safe to say you don't have 500 developers at your disposal to go ahead and recreate your UI or your design system across other frameworks. So you need another solution. So here's another Nathan Curtis quote. I think really shows the value of what we're striving for in an ideal design system. And that's a design system's value is realized when products ship features when using parts of that system. So basically, the only way you get any real return on your investment of a design system is when the design system itself is actually used to ship the actual products. Brad Frost in Atomic Design refers to this as the design system holy grail, which in practice looks like this. So you have your designers and your developers, they're working together, and they decide that they need to make changes to a pattern. That informs a change to the design system, and that therefore, when you change the design system, that automatically updates both the websites and web apps that use that, as well as the pattern library that everyone's referencing to see how this is supposed to work. Now, for this to actually work, the code in this design system needs to be so easy to integrate with that it would be more work for a team to not use your design system. Otherwise, if it's not that easy, then no one's going to use it. You can build it, but it's only going to be used within your small sphere of influence, not across an entire company. And you can't build it with a single framework because frameworks don't play nice with each other. And you can't build it in multiple frameworks because you don't have hundreds of developers tasked with just recreating the same thing in all the frameworks your company may be using. Now, you could try to go just all vanilla and share JavaScript and CSS, and that'll get you part of the way. But then you need to go ahead and share a markup. And I've tried sharing like mustache templates across teams that use Node and Ruby and .NET, and it just doesn't happen. It's really hard to actually have teams that are using different technologies even share the same piece of code, even if it can be shared, if there's technical ways to do it. So what you need is something that will help you to create this holy grail of solutions. And that is where Google Polymer comes into play. So Google Polymer is actually a project. It's not just one thing. It's made up of 4 parts. First is the Polymer library, which is basically some sugar on top of web components, which I'm going to cover shortly. They also maintain the web components polyfills, which bring these powers of web components to browsers all the way back to IE 11. They also have a whole set of open source web components that are built with Polymer. And also the Polymer team is part of the Chrome team at Google. So they have members that are basically in charge of helping to move the web platform forward. And when you hear the Polymer team talk, they often use this phrase, use the platform. And basically this is just them saying, you know, for the past 7 years, we've been trying to push the standards forward that are in HTML and CSS and JavaScript to make things easier to use for web developers. And really their goal is something that looks like this, which is how we develop our applications now. You've got the web platform at the bottom, which is your HTML, CSS, and JavaScript. On top of that is web components that are built with Polymer or without Polymer. You can use other libraries or just vanilla JavaScript to create web components. Then you have your existing frameworks to build these applications. So you can use frameworks with web components to orchestrate what you need to do across your app. So I've been saying web components a lot. I'm going to make sure we're all kind of clear on what web components are. So there are 4 original specs that make up web components. The first is custom elements. So this provides a way for authors to build their own fully featured DOM elements. Like this is an example of an XC tab element. It doesn't exist in the HTML5 spec, but you can go ahead and create your own element in that case. There are HTML imports, which this spec is dying or close to being dead, unfortunately. But the concepts here are kind of living along. So first, to cover what it is, it's a means to import custom elements. It has built-in deduplication, so if you import the same import twice, the browser won't download it again. It componentizes the HTML, CSS, and JavaScript. And as I mentioned, since this is a kind of, browsers couldn't agree on the right way to use this, so this is going to be replaced with ES6 modules, and you get basically the same benefits of HTML imports with ES6 modules for the most part. And also point out that if you use Webpack to create your websites, there is a Polymer Webpack loader that will understand your HTML imports and then convert them to ES6 modules. So the current version of Polymer is Polymer 2, and that uses HTML imports. Polymer 3 will switch to the ES6 syntax, so if you're using the Webpack loader now, you'll be able to switch to Polymer 3 with basically no changes. You'll just keep using your same Webpack loader in that case. The third part is templates, and this is used to declare fragments of HTML. So in this case, if you see a template tag on the page, that itself will render nothing. That's just there for you to go ahead and then select that template with your JavaScript and then be able to use that to clone that content into your DOM later on. And the last part, and the most powerful part, is the shadow DOM. So this allows you to take a DOM subtree and hide it from the document scope. And it'll also hide CSS styles as well, which we'll see is really where this comes into play with web components. And common examples from HTML5 include the select element, the video element, and input type equals date. So if you think about these, those all have additional UI to them that you as web developers have limited or no ability to customize. And that is using the exact same thing that Shadow DOM is. In practice, here's a very simple example. So this is paper tabs, which is material design tabs from the Google Polymer team. The code on the bottom shows you've got these new elements, paper tabs and paper tab. And those go ahead and create that first tab, tab 2, third tab rendered on top of that. All just with some simple markup that the user can use to create this material design UI. And they've open sourced a whole set of paper elements that go ahead and allow you to create material design if that's what you want to be able to do. So if you're not using material design, how do you go ahead and build your design system using Polymer? So here's the last Nathan Curtis quote of my talk, I promise. So it's a style guide is an artifact of the design process. A design system is a living, funded product with a roadmap and backlog serving an ecosystem. So the key here is you need a collaborative solution with designers and developers that is its own product. It's not this project that just goes on the side and then kind of dies or has someone half maintain it. It needs to have as much love and care as an actual product that you would ship to customers. And to build that, you need a team. You don't need 500 engineers or even 70, but you need a dedicated team. And for what that team's mission should be, there's this quote from Gina Ann when she was on the Salesforce.com design systems team. And she basically stated their team's objective, and I think it really embodies what you should be striving for. And that is to establish a high-quality, brand-aligned experience across our product through human guidance and internal tools. So the key there is human guidance and internal tools. You have humans using your design system, and you need to give them the tools so that it's easy for them to do that. So the members of this team need to be the craftspeople charged with building these components for all the other teams of the company to use. And they should also allow other teams to contribute back. So this is kind of the inner source model, which are basically the open source practices applied to a company where other teams can go ahead and if they're using a component in the company, they can submit pull requests to that, and then this team will be in charge of reviewing those pull requests to make sure that they meet the design system standards. Now, that doesn't mean they need to go ahead and build everything from scratch. There is a whole bunch of open source web components that are available at webcomponents.org. They're broken down by collections there. You could also search. And then the most popular collection that we use at Comcast are the iron elements. So basically, if you go back to the paper elements, most of the paper elements are made up of iron elements, which provide functionality, and then they apply material design to them, and that makes a paper element. So since at Comcast, we're using a lot of functionality of iron elements, we can mimic the same process. So we just, instead of applying material design, we apply our own UI to that. So what I recommend doing basically is if you see a paper element that you like and you want to have it match your style guide and your UI, look at how they built it, and you'll see the iron elements they used. You can then use those iron elements to create your Polymer web components. So how exactly to go ahead and then add those styles to these iron elements? So for that, I'm going to get deep into some code for building web components with Polymer. And I'm guessing you've probably seen this image before on a mug or a t-shirt or just on a website somewhere. And I actually believe CSS is awesome. There's some awesome aspects to it, but there's some parts of it that make it hard and difficult to use, especially when you're maintaining a large website over time. So I was coming up with a list of basically why CSS is hard. And then when I was researching this talk, I found another talk by Philip Walton at Google, and his list was better than my list. So I'm just going to go ahead and share his list with you. So his list is basically managing global names is an issue. Scoping and isolating styles. How do you have your styles actually work for only a small element in your code? Specificity conflicts. You keep, that's where stuff like @bang important ends up, which is a big issue. Unpredictable matching. If you have unspecific selectors, you have no idea what could be impacted if you modify them. Managing style dependencies becomes tough. And then removing unused code. Whenever you're refactoring, it's always great to be able to remove code, but in CSS, you're like, if I remove this selector here, is this actually going to go ahead and cause an issue? It's tough to know that unless you have a fully automated screenshot QA system. And this is why the issue with this is basically not so much the properties, but the selectors. And this is why things like object-oriented CSS is popular, and SMACs and BEM. But there's one thing that can handle all of that, and that is the shadow DOM. So to learn about that, let's actually get ahead and look at some example code here. So here's the markup you'd find in a very basic Polymer element. The important parts here are, first you have to import Polymer element.html. This is the Polymer 2 way to do things. Inside of a DOM module, the template, you'll have your styles. And in our example, this is where we'll be adding some styles to kind of see how shadow DOM works. In our example here, we just got a paragraph tag inside the template that says shadow DOM is awesome. And then this is your Polymer boilerplate. So you have a class that is extending Polymer element. You've got this standard getter, which is returning the name of your custom element. And then you call custom elements.define, passing it that string, and then passing it your class. And this is the very basic how to get a Polymer component up and running. Now to actually go ahead and use a Polymer component, here's an example in our index.html file. So important things here, you'll need to load the polyfills if needed. So Polymer 2 has this nice web components loader.js script that will go ahead, feature detect what the browser you're on has, and then load the polyfills that you need if you need any at all. You'll then import the my element HTML file. So this is the component you're going to use. If you forget to do this import, then it'll just basically fail silently. So there is a Polymer linter to kind of help you in case you do forget that. And in our example here, we're modifying the styles in a style tag, just the way you add styles to HTML, the same way you've been doing for years. And in our examples here, our body contains that my element custom element and a paragraph tag. Now when that JavaScript processes that code right there, and it upgrades the my element tag to be a fully featured web component. And if you were to inspect that in Chrome DevTools, you would see what's known as the flattened DOM tree, and it would look like this. So you have the my element, and inside of that is the shadow root, which is where the shadow DOM starts. And then you've got your style tag and your paragraph tag. This was the stuff that was in the my element template there. OK, so let's go ahead and actually add some styles and see how the shadow DOM works. So I'm going to say in the custom element, my element, all paragraphs will have a 3-pixel solid orange border. And in the main document, all paragraphs will have a light blue background color. And this is your end result. So you've got showing basically how the shadow DOM works. So you've got styles that are in the shadow DOM, just apply to the shadow DOM, and those outside the main document only apply to that, and they don't apply to the paragraph tag inside of the custom element. So this is kind of the huge win at the most basic level for what shadow DOM and custom elements give you. Now, if I wanted my element to have some styles in it, what we can do is use this special host selector. And the host selector will select any element that has a shadow root. So inside of the my element template tag and its style tag, you would then put the host selector there to add styles to that element itself. So if I were to, for example, make the outline blue and dashed, this is how you would add that. But you notice it actually didn't add that dashed blue outline around it. And that's because elements in HTML5 are display inline by default. So with this is going to do nothing because there's no height to it. So if I go ahead and make it display block, then you get that blue dotted border around it. Another thing I recommend adding to your custom elements main styles is this contain property. So this right now is only supported by Chrome, and it's basically for performance reasons. So what it does is when it comes to repainting, it basically says, I want you to contain the scope of your repaints to this element itself. And the content value there is actually a special property that covers style, paint, and layout. And that gets into a few different things, which you can basically go to this website in the bottom to find out all the details of. But at the high-level overview, what it will do is basically scope some things like CSS counters. If you wanted to have that, it would impact only that element and not the ones outside of it. It also essentially clips the element, and it gives it a new stacking context for z-index. And it basically behaves as if you had that element on a page with the HTML bodies margin and padding set to 0, which is why you have kind of this space that appeared right there once we add this contain equals content there. So if I go ahead and I add a margin 0 to that paragraph tag, that's going to go ahead and undo that, because it was basically just, in this case here, the paragraph by default has a top margin and bottom margin. So if I margin 0 that out, then we're good to go. So again, for your host element, you want to be adding display often. You often be adding this content contain and probably some other properties in that case. So now I want to show a couple ways to give control to the user of your element regarding those styles. So the first thing is you could add some styles that handle attributes. So for example, here this is saying if the element is disabled, we're going to apply some new style to it. So if I go ahead to the markup of the page in index.html, and if I go to my element there, and I add the disabled attribute to it, then these styles apply to it there. And you'll notice that the way it works, basically you have hosts, and in parentheses you have the selector that you want to target in that case. So that's one option. I'll undo that, and we can go to another option. So that was the markup there. I'll get rid of those styles on the left there. And then if we look at the index.html markup, we switch that over to the styles. Right now we just have the paragraph tag there. And we're going to go ahead and actually try to style my element. So here I went ahead and actually changed the outline color. So I'm overriding what was set in the host. And this is ways you can go ahead and modify that directly. Now I can't go ahead and try to target the paragraph tag inside of my element, because that is inside the shadow DOM, so that I have no access to. All I can do is basically override the stuff that is in the host, not override the styles that are in the children of that in the shadow DOM. Now there is one other way to allow users access to style the elements that are deeper in the shadow DOM. But before I get to that, I want to cover one other part of that, which is what's known as slots. So I'm going to undo the things I just did there. We'll take away the other styles there. So we'll switch back to index.html, and we've got my element. And we want to add some content to that, actually. So I'm going to go ahead and put a UL inside of that as the children. And ULs obviously often have an LI there, so I'll add some content in that case. Now for that to actually appear in our rendered result, we need to go ahead and update the markup. So here in my templates markup in the template tag, I'm going to go ahead and underneath the shadow DOM is awesome paragraph tag, I'm going to add a slot element. And that's where then it tells the content to say, this is where my content needs to go. So it's going to go ahead and render the content that were children of my element into the slot when it actually goes ahead and is rendered. So its flattened DOM tree now looks like this. It was the same thing it was before, and then we're going ahead and saying in our slot element, add all of the content that was put into it. And it's important to note it doesn't actually physically move the DOM nodes. All it's doing is actually rendering them at this location. So in the DOM, this is the flattened DOM tree, but the DOM still has those ULs outside of it. Now there's a couple ways to style that slotted content. So the first is this slotted pseudo element selector, which takes a top level child node as an argument, which in our example is a UL in that case. So if we set margin 0 to there to remove the default margins from the UL, then we can handle it that way. And then if we go ahead and we try to select something that's deeper into it, then that you cannot actually style. So slotted only can handle the top level elements, so the first children of it. So since that's not going to do anything, I'll remove that slotted UL LI on the left there. Now if you look again at the index pages styles, we need to go ahead and try to style, for example, an LI item. We can add that there, and that will change the color to red. This kind of makes sense because that markup was children of the my element, and it's in the main document, so we have the ability to style that. If I were to go ahead and try to change that to a UL, that'll still be red, that's fine. And notice that the slotted UL there on the left-hand side, if I try to change the color, to be blue, the styles in your main content will then win over the styles that are in your slotted selector there. But if I remove that UL red from the index HTML there, then we get the blue styles. So for this reason, when I'm styling slotted content, I rarely actually set slotted styles unless there's a predictable pattern that I know that, if something is added as a children of this, that I know I'm going to handle it some way unique to this content. An example is, again, with paper tabs. You know there's going to be a paper tab there, and maybe you want to style the first child in a certain way to add additional margin or padding or remove margin or padding. That's really the only time that I end up using the slotted selector. And there is one other thing I'd like to cover regarding styling content in the Shadow DOM, and that is the behavior of inheritable CSS properties. So inheritable CSS properties have actually always been part of CSS. This is basically properties that when they're set, they propagate down to the children. So if you set a color or font family, that will propagate down to the children. If you set margin on, say, the body tag, that's not going to apply that margin to every child element on the page. Those are not inheritable properties. So I'm going to go ahead and I'm going to remove that blue color from the slotted UL there. And let's bring up the full styles for my template again on the screen there on the left there. And I'm going to set some CSS properties that inherit in our index.html page on the right. So I'll set a color and I'll set a font. So I'm going to make the color green and change the font family. And you'll see that this applies to the styles in the main document as well as in the Shadow DOM. So this actually, in this case, when it's inheritable CSS property, it does pierce the Shadow DOM. If you want to stop that from happening, you can actually do that by setting a property on the host. And any CSS property you don't want to have this inheritable property impact it, you can set initial as the value of that. So here we're saying, I want the color to be reset to be the initial. It's not going to inherit from its parent. You can actually do this with all properties by using the keyword all, except for this doesn't work in Edge. So the only time you're going to be using this in reality is if you're developing something that's only for mobile. Say you're developing just in web views, then you might want to use this. But otherwise, you're kind of stuck, at least for now, to actually list out the individual properties that you want to stop this inheritance from happening. Now, I mentioned earlier that there is one more way for web component authors to provide custom styling abilities for the users of their components, and that is with CSS custom properties. This is also known as CSS variables, but when you see how they work, you see that custom properties makes more sense for what their name should be. And if you were in David's talk earlier about the observable future of animations, you saw at least the peak of this earlier. So this is the basic usage. You basically, in a selector, typically the HTML selector, especially in Polymer, you then define a custom property with this kind of double dash syntax at the start to give it a variable name and then what the value will be in that case. And then to actually go ahead and use that custom property, you call var and you pass it the name of the custom property that you want to use. And these can have fallback values, which is great for when you're building components because you may want to have a default value if one isn't specified. And you can actually nest these multiple levels deep. So I'm not saying you want to use these variable names here, but at least shows you can keep going as far down as you want to with different default values. So you can basically make sure that some value is applied for your selector there. It's important to note that there's nothing here that's specific to Polymer or web components. This is actually just the way CSS custom properties work. But they're even more useful when it comes to Shadow DOM because they can reach into it. So here's an example of how that works. So this is back to the code we had before. I haven't changed anything yet. So we're going to go ahead and look at the paragraph tag styles on the left, and we're going to adjust the border there so that it's going to use a CSS custom property. The default value is going to be that same orange, but we have the ability to override it with that my element border color. So if I go to my index.html and then I try to use that, I can then go ahead and override that with purple. So this is a way to show that if you created a custom element and there's no way to access that paragraph tag border color, this is the way to expose that to users so they can go ahead and actually modify that to their needs. So you can see that CSS custom properties are actually pretty powerful. And here's a few tips for using them that are pretty similar to how you would build stuff with Sass or less and that kind of things, but they apply just as well here. First is to basically name your colors. We do this often. We, instead of saying, crazy hex values, we give them a color we can reference. We then can set variables for their usage. So all of our links are referencing one color there. That way, if we decide to change the color of links across all of our Xfinity products, we just change it in one spot as opposed to having to change it in possibly hundreds of spots. It's also useful to name your custom property hooks in the format of your element name and then your property name. So that way, basically, it's pretty clear on what this CSS custom property is going to do. So for example, if I take away the element part of that my element border color, you're left with border color. So it's pretty clear what you're going to be updating when you modify that CSS custom property. And besides color, it's also nice to kind of modify to define gaps or padding factors or gutters. So one way is to basically just define what all of them are, but there are certain values, or you can actually just have a main value and then use calc to just base all of your stuff off of that. Now, these CSS custom properties are great, but you may want to either apply multiple styles to a selector, or instead of creating these hooks, you might want to just say, you know what, I don't want to have to list out 10,000 different individual CSS properties. I want to just say if someone wants to add some CSS to my custom element, I want them to be able to do that. And that's where CSS mixins come into play. So everything I've talked about so far is not specific to Polymer. This is the one piece that is. So CSS mixins are a Polymer-specific thing. So let's get into that. So this is a proposal. It's not officially adopted yet, so when you're actually using CSS mixins in Polymer, there's a polyfill for the proposal that's being talked about right now. And also important to note that these are not Sass mixins or any other preprocessor or post-processor mixin. So just forget about what you know about those for a minute or two while we talk about CSS mixins in the concept of what they actually are in the spec that's being written. So this is essentially where we left off in our last example, except for two additions. So instead of importing Polymer element, I am importing the entire Polymer library. Another option would be to still import Polymer element and then import the shady CSS apply shim, but basically you need to make sure you pull in this part that you need there. And then we've added this add apply statement here. So we're saying, okay, my element P is the name of our CSS mixin. And again, I'm using the same naming convention as before, which is the element name and then what I want to provide hooks for. Then the way to go ahead and define mixins is nearly the same as you would be defining any other CSS property. But there's a slight twist to it, so just stick with me for 30 seconds here while I go over that. So you've got your selector like normal. You've got your mixin name, which has that -- prefix, then a colon, and then this is basically exactly the way we define any CSS property. Then it gets slightly different because you then add curly braces, and then you need to remember to add a semicolon. And for some reason, because you're so used to just writing curly braces without a semicolon at the end, this seems to trip me up. When I was working on this slide at the office, someone literally came to me and said, I'm having an issue with CSS properties. You know, they're not CSS mixins, they're not showing up. And it was because he didn't add the colon and the semicolon. And probably because he just copied my code when I forgot to do it before. So if you learn nothing from my talk, just remember your colon and semicolon when you define CSS mixins. It'll save you an hour of headaches down the road. Then once you have that, you just add your rules in there the same way that you always would. And you've got the power of CSS mixins in your hands at that place. One thing to note, if you are adding styles to the main document, like I'm doing in my examples here, you need to wrap them in this custom style, which is a Polymer element. And the selector in that case will be HTML. So replace selector with HTML always in that case. So back to our code here. This is just where we left off. And let's bring up the styles that are in the main document right now. And we want to go ahead and define that mixin on the HTML tag. So I'm going to go ahead and say I want the background of the paragraph tag to be red and the font style to be italic. And this didn't show up because I need to go ahead and add that custom style wrapper, so I'll add that. And then that goes ahead and then actually adds my mixin to it in that case. Now, if you're going to go ahead and actually inspect the style tag in my element with Chrome DevTools, like the actual style tag, not the element itself, but the style tag, you get to see kind of how this actually is polyfilled. So here is what it looks like after that shim is applied. And the important things to note here are, first off, it's created some custom properties that are prefixed with the exact same name as the add apply declaration there. And then the actual properties are set are the ones that we define in the mixin there. So that's basically how it creates that. And then it adds this weird underscore dash underscore in between the two. And that's how it builds these CSS custom properties for that mixin. Then if we inspect the custom style tag in index.html, We then see where those custom properties are defined and then where the value came from. And that's how the magic works for these CSS mixins in Polymer. So a few notes on that custom style tag that I've mentioned a few times. So you need to use that when you're setting styles in the main document, either if you're declaring it directly in the main document, like my example did there, or if you want to use an HTML import and have those styles applied to the main document, then you would just have an import with the custom style tag there. Now, when would you want to actually go ahead and do that? Defining @font face rules is a good time to do that, as well as theming. So if you're going to declare a set of common variables and mixins, you're going to want to do that in a custom style tag in an import that you pull in. Also, custom style and @apply can be loaded on their own via shady CSS if you really want to kind of trim down what you're shipping to customers. You can see it there, but again, you can just use Polymer's full library and get that if you want. One thing to note in Chrome, if you're going to be using HTML imports with custom style, you're going to get this warning. And that's basically unavoidable, but if you're using Polymer 1.10.1 or 2.1.1, then you're good. Basically, in that version of Polymer, it will go ahead and take your custom style tag and physically move it out of the import and into the main document. But since Chrome sees the initial declaration there, it doesn't undo the warning. It's just always going to be there. But you just need to know that you're using the right version, and then you're good to go. One other way to share styles in Polymer is with style modules. So the way that those work are that's Polymer's way of sharing styles among Polymer components. And they're actually copied into the shadow root of the component they are included in. So because of that, you don't want to include a whole bunch of styles. You only want to include what you actually need. And this is a great way of sharing form element styles, like buttons, because basically in the V1 custom element spec, you are not allowed to take an existing HTML element and then extend that. So this allows you to keep all the good accessibility features that are built into buttons, for example, and maintain that and then just update the styles. So quick look at what these look like. This is a new custom element, which is pretty similar to what we did before, except now we have a DOM module with an ID. That's the key part of custom styles. And then when you go ahead and then try to use custom styles, you want to make sure you first import the styles again. And then in your style tag, you then have this include attribute, which you pass it the value which is the same as the ID from the styles that you're importing. And that's how you include those in them. And then you can go ahead and then add additional CSS in your style tag the same way you always have before. Now you might be wondering, can you actually go ahead and use Polymer and all the stuff I'm talking about? And we've been using this at Comcast for over 3 years now, so the answer definitely is yes. And the reason that's possible is with those polyfills. And this is a look at the current matrix of browser support for the aspects of web components, which Polymer is built on top of. And the cool thing here is that if you look at Chrome and Safari, it's actually green all the way down. So if you're developing for mobile right now, you pretty much have 100% web component support in those devices. So you can go ahead and build that, and you don't need to add any polyfills, which is great. Makes your site fast, and this is really powerful. But if you need to build for other browsers, then you need to go ahead and polyfill things. And it's actually technically impossible to polyfill Shadow DOM. So what the team has done with an eye for performance is create this thing known as Shady DOM and Shady CSS. And basically, all the examples that I showed you so far will work in Chrome and Safari, and they will work with the polyfills. But if you were to go ahead and actually try to use some more advanced features, you might get caught up with some of the limitations of Shady CSS. So I'll cover those real quickly. First, your slotted selector needs to have something before it. So if you just put host there, that's totally valid, and that'll do the trick for you there. If you like including external style sheets, you can't do that within a shadow root. So just in your custom elements, you can't go ahead and do that. Also, you need to avoid dynamic changes, which includes changing a custom property value or adding styles after the shim executes. And that includes basically if you want to set CSS custom properties based on a media query, you can't do that. Although I should caveat that by you actually can do this, but you need to call a function after the fact because it needs to do a lot of processing again. So I just kind of would recommend just avoiding that. If you want to see more of the details there, I'll put the link there as well for what the limitations are and more details about that. Another option then is actually just not to use Shady DOM and Shady CSS. YouTube recently launched using Polymer, and they actually don't use the Shadow DOM. So that is a possibility. And the way you might want to do that is, okay, you want to start using Polymer and you might have this kind of big CSS file you want to import. So maybe the way to kind of get introduced to that is to go ahead, use Polymer, import your CSS, but don't use Shady DOM. Instead, just kind of use whatever styles you have there using something like BEM. But if you're using a new project, or especially for mobile, since you have native support, we would recommend going ahead and using Shadow DOM in that case. All right, so I'm going to cover just a few more tips for creating web components with Polymer for when people want to actually go ahead and use your code. The first is make sure you document your elements. Polymer has built-in support for generating documentation using a combination of Markdown and HTML comments and JS doc. So if you follow the instructions here, this will go ahead and create your documentation for you with this iron component page element. And what that looks like is something like this. So this is Paper Tab's generated documentation. And this was just generated from an HTML comment with some Markdown in it. You often want to include what CSS custom properties you're exposing, which is, again, just an HTML comment with some Markdown. And then when it comes to actually your JavaScript properties that you define, this is all just based on JS doc syntax. And on these documentation pages at the top right, there is also a link to a demo page, which is something that is really key to building shared components. It's so important that basically the way we develop at Comcast is based off of this acronym I came up with, which is DDD, and that stands for Demo-Driven Development. And what that basically means is when you're going ahead and you're working on a web component, you want to go ahead and be looking at the demo page constantly. And when I go ahead and review someone's code, the first thing I do is look at their demo page. And if their demo page is broken or doesn't show what I'm supposed to look at, I just reject their PR and say, make the demo page work. And here's an example of one of our demo pages. So this is the Xfinity Home ARM disarm component. The top one shows what it's like on the Xfinity Home web app by default. And then if we want to include that on another web app or website, we have a smaller version of it. So this way we can basically, as we're developing updates to this, we can just look at the demo page and know how it's going to work not only in Xfinity Home, but in other web applications. So then that way, when I make a change to it, I can feel confident that the change I'm going to make is not going to break anything because I have every example in the demo pages there. You can also include styles as well. So we have all of our styles broken out, and we have demo pages for that. So you can include, for example, maybe your colors, how your typography works, form styles, and stuff like that. I also want to touch on this thing known as the gold standard for web components. If you're developing and you have a careful eye for accessibility, which you should, this gold standard gives you some great tips for what you should be looking at and testing in your components to make sure that they are accessible and will work well, kind of based on the same way that actual HTML elements work themselves. And there's actually a library you can check out at elix.org, which has a bunch of components that actually meet the gold standard. Last part about building things that I want to touch on is how you should structure your code. Specifically, should you use a monorepo or a lot of repos? Now, at Comcast, we started off with having lots of individual repos for every individual component, because that's what the Polymer team's open source project was set up. But if I were to go ahead and restart now, I would do a monorepo or at least a few larger repos, because what we've ended up doing is basically if we make an update to one component, and that's, say, a dependency on 10 other components, then we need to bump the semver in one that end up bumping the version of 10 other components. We just have someone that's just like in charge of updating versions all day long, which is not what we're going to be doing. So definitely stick with the monorepo approach for that. Now, if you want to go ahead and actually use the things that you're building, how are teams going to go ahead and use your components? So originally the way to do this was with Bower. So Polymer 2 and before uses Bower as the dependency management system. But Bower is now deprecated, so the way that the Polymer team recommends to work moving forward is with Yarn. So Polymer 3, which should be released at the beginning of next year, expects you to use Yarn with NPM modules. And if you use Yarn, you need to make sure you have this flat equals true option so that your dependencies are installed in this flat dependency tree. If you want to know why, there is an incredibly, incredibly long thread on GitHub where basically the Polymer team says why they need this, and the NPM team says why they will never have it. But then the Yarn team is like, we give this to you, and that's why it's basically, as far as they're saying now, this is the way to use it moving forward. Then once you have, the other way to import it, one is with the dependency management. The other one is to actually put your components on a CDN, reference that, and then bring them in. So you can insert the tag the same ways if it was part of a local build, but it's actually hosted somewhere externally. And we actually do this at Comcast with a component we have called Polaris, so that header and footer at the top there is actually built using vanilla web components, not even using Polymer. And the advantage of that is that it's really simple to use. So teams that want to use this element, all they do is import the JavaScript for it. They include the header tag with some customizations that they need to, and they add the footer tag. And this makes it super simple to use for other teams. And also, since it's universal header and footer, when we make a change to it and deploy to the CDN, that change gets pulled in across all of our websites without a deployment, which is really powerful in that case. This is actually open source, so if you want to go ahead and see how we did that, it's on our GitHub page there, so please feel free to check that out. OK, so I went a little bit over. Sorry about that. Still have time for snacks. But to quickly wrap up, here's what I want you to take home. Make sure you have a team of designers and developers that are responsible for your design system. Polymer and web components are a great way to build reusable components that work across multiple frameworks. Don't forget those colons and semicolons when you're going to be using Polymer CSS mixins, and embrace demo-driven development. So if you want to learn more, here's a bunch of links. Again, I'll tweet this out and I'll put it in the Slack channel so you can check that out later. Chris Lorenzo is going to be talking about decoupling with Google Polymer in Fantasia C right after this. So check that out. His talk has a bunch of jokes and some cute pictures of his kids, so you won't be disappointed. That is it. So if you have any questions, reach out to me either here, I'll be at the after party, on Twitter, or in Slack, and enjoy the rest of your time at the conference. Thank you.